Good evening. Welcome to the first installment, welcome to the first installment of the State of Science. Today we are focused on building the COVID-19 knowledge base in real time. I'm Lynn Miranda, Professor of Applied and Computational Mathematics and Statistics, as well as the Charles and Jill Fisher Provost here at the University of Notre Dame. And I'm so delighted that all of you are here joining us, whether you're from Notre Dame, another university, or just saw something about this talk and thought it would be interesting to hear from Holden Thorp. I'm certain that you will find it interesting to hear from Holden. This is the first in a series of 3 conversations with Holden that we'll be having over the course of the next couple of weeks. Holden serves as the editor-in-chief of the Science family of journals. I'm lucky to call Holden a friend and a colleague, and I always appreciate talking through complicated issues with him. So having him here to talk about building the COVID-19 knowledge base in real time, which is a complicated issue, feels like just a really special opportunity for all of us. Before we get started, just a couple of logistical notes. We want this discussion to be as interactive as possible. Right above where you see this video streaming to you, there's a question box where if you want to submit a question, just punch on that button and send your question in, and I will try to relay as many of these questions to Holden after we walk through a series of initial questions. Also, when we're done here tonight, the video of this conversation will be posted on the very same place where you're tuned in tonight. And we're also going to be converting some of the material today into a podcast that is part of our With a Side of Knowledge. The podcast is called With a Side of Knowledge. So there will be plenty of opportunities. If you didn't get enough tonight, there will be plenty of opportunities for you to catch up with what Holden has to say and how to think about this COVID-19 knowledge base that we're trying to build. Before we get to questions, I just want to tell you a little bit about Holden. He's the editor-in-chief of the Science family of journals. And so what do we mean by Science family of journals? Well, there are 6 journals published by the American Association for the Advancement of Science. They include Science, the premier global science weekly, as well as Science Translational Medicine, Science Signaling, Science Robotics, Science Immunology, and the open access journal Science Advances. While serving as editor-in-chief of Science of the Science family of magazines, Holden is on leave from his professorship at Washington University in St. Louis. There he is the Rita Levi Montalcini Distinguished University Professor. He holds appointments in both chemistry and medicine at WashU. Previously, he served as WashU's Provost, and before that, he was the Chancellor at the University of North Carolina at Chapel Hill, which is his alma mater. Of course, my alma mater is Duke, so we have a little bit of a rivalry thing going on between the two of us. Go Devils, Holden. After finishing his undergraduate degree at Carolina, he did his PhD in organic chemistry at Caltech and then his postdoc at Yale. Not too shabby credentials. In his research career, Holden has also developed technology for electronic DNA chips and co-founded Viamet Pharmaceuticals, which is developing new drugs for treating fungal diseases. Now, what you may not know, all of those sorts of things you can find pretty easily. What you may not know about Holden is that he had his first theater appearance at age 3 in Carnival. He formed a garage band as a teenager, and he's written several musicals. So he's a very multi-talented individual. In the summer of 1981, at the age of 17, so you can back calculate how old he is today, while studying guitar at Boston's Berklee College of Music, he won first place at a $500 prize in a Northeast regional competition to solve a Rubik's Cube puzzle. So I'm sure many of you remember Rubik's Cubes. His motivation for entering the competition was he wanted some money to buy jazz records. We'll hear more about that later. And of course, there's the little known fact, or maybe everybody knows this, that there is an episode of the television sitcom Frasier, and that episode is called Holden Thorp. And that's not a coincidence. So we'll see whether we can find out the reason for that. So, hey, Holden, welcome to the State of Science.
Great to be with you. Thanks for inviting me to talk to you today. I'm looking forward to it.
Absolutely.
And I have various kinds of I have some Rubik's Cubes, and maybe I'll show you at the end that are historically significant. So.
There we go. We'll get your take on the best algorithm for solving a Rubik's Cube. Okay, so let's get started talking about building the COVID-19 knowledge base. So take us back to the early days of the pandemic, February, March, April of 2020. When did you realize how large of an impact COVID-19 was going to have on all of our lives?
Yeah, it's a great question. I mean, when last year the AAAS meeting was in Seattle, and it was right around this time, my phone has been reminding me that the pictures I took on that trip are all a year old the last few days. And we debated whether we were going to go and have the meeting, like a lot of these conversations that have been happening, but we consulted with the public health people in the state of Washington and decided to go ahead with it. In retrospect, we were very close to where a lot of this was getting started, but fortunately, to my knowledge, no one, at least at our organization, got COVID on that trip. But there was a lot of talk even then about this, and Bill Gates gave a big plenary lecture at that meeting, and he said he was very worried about coronavirus then. When I got back to the office, the person who works with me, who does life sciences for us, Val DeVinson, came in and said she had the structure of the spike protein submitted to us by Barney Graham and Jason McClellan. And I said, "What's the spike protein?" I didn't know. It's now the most famous protein in the world. I think it's passed insulin as the world's most famous protein. We could debate that later if you want to, but I did a Twitter poll as to whether the spike protein was now the most famous protein in the world, and it won pretty handily. So, you know, we rushed the spike protein structure straight through, and within another 3 weeks, we had sent everybody home. And then I started getting papers saying things like we were going to be in lockdown for 6 months, which seemed like a long time. But by April, we ran a paper from Mark Lipsich's group that turned out to be pretty accurate, that it was going to be about 18 months, and then we might have periods on and off after that. So, you know, that was kind of between the middle of February and the middle of April, I think, is when this became pretty obvious how big it was going to be.
So in a role like being editor-in-chief of science, how do you balance the need to disseminate good science in the most expeditious way as possible, while at the same time making sure that the science is subjective to significant peer review?
Yeah, well, at the very beginning, can't remember if it was before we went to Seattle or right when we came back, but sometime in February, we agreed with our sibling journals, Nature, New England Journal, JAMA, Lancet, and several others, to a set of principles that we were all going to use to document this. The first would be we wouldn't put any of the final versions of the papers behind the paywall, which we haven't done. We don't do that for public health papers anyway. So for us, that was no big deal. We would have done that anyway. We encouraged everybody who submitted to us to post a preprint. We can't force people to do that, but we like preprints because they take the pressure off of us to go as fast as possible. And so a preprint, for those who don't know, is basically usually the version of the paper that you've sent to the journal. You post it on a server somewhere, and that allows other experts in the field to look at the data so that the science can keep moving forward. And then we agreed to review things as quickly as possible. Our record was the spike protein paper we got on February 10th, and we published on February 19th.
Wow.
That's a testament to my colleagues, the editors and the proofreaders and copy editors and all the operations people that do the posting. but it's also a testament to the reviewers who turned it around that fast. We've come close to that on a few other really important papers, but in every case, we've always felt like we had whatever time we needed to get it right if the preprint were already out there, because we wouldn't be holding back progress towards conquering the pandemic.
Okay. So something you said has caught my attention. So that kind of conversation and collaboration with the other editors from the major science publications, is that common, or is it something that was spurred on because of the pandemic?
I think it's pretty common, but it's a lot like when we were both provosts and we would have meetings together, even though our schools sometimes competed with each other in sports or for hiring faculty or various things. There were plenty of things for us to collaborate on and commiserate about and support each other on. And it's very similar with me and Magdalena Skipper, who runs Nature, and Eric Rubin, who does New England Journal, and John Pham at Cell, and Richard Horton at Lancet. There's a bunch of us that meet periodically to get together. We have very collegial relationships.
Okay. So Holden, we're spending a lot of time talking about vaccines right now, and I'm going to get to that in a minute. But it wasn't that long ago where we were struggling to figure out how to test for the coronavirus. So what were some of the biggest hurdles in figuring out how to test effectively for the coronavirus? And are there lessons learned that can be applied in future situations?
Oh yeah, well, the biggest lesson is that the United States was not even close to being ready to get testing where it needed to get. There was not a sense of urgency from the top, that's for sure. But it's also true that that the CDC made some very big mistakes. First, they turned down using the World Health Organization's test, and then they botched their own version of the test. And that cost months and really, unfortunately, set the tone for the United States to underperform the world when it comes to tackling COVID. So the testing was very important, but as I remind people, imagine if COVID had come along before we had PCR. I mean, it's for some of the younger people watching this, they probably don't remember a time when we didn't have PCR, but you and I were both already well into our faculty careers.
I remember a time when we didn't have personal computers.
Yeah, okay, right. So imagine if we didn't have PCR, we wouldn't have had a way to do the testing and the sequencing and everything that needed to be done. So on the one hand, the technology and the basic research that went behind it was in a very good place, but the preparedness of the federal government to prepare and approve tests and deal with deciding whether to do its own test or whether to use another country's test, we were just not ready for any of that. And we need to be in much better shape when the next pandemic comes around. Hopefully we will be.
Okay. What's your sense of progress toward treatments that might be used to greatly dampen the symptoms of COVID-19 if you become positive? So something like the equivalent of Tamiflu, except for seasonal virus, except for seasonal flu, except for the coronavirus. What do you think are the most promising treatments?
Well, I think it's early to tell. I think it could be an inhibitor of the reverse transcriptase, or it could be an inhibitor of the main protease. We published all those structures, and at the time we said, hopefully this is what we can get a small molecule to, just like we have for HIV. We have protease and reverse transcriptase inhibitors, and there's no reason why the same thing can't work for coronavirus. The problem is that to get a novel small molecule all the way from being synthesized into and through the clinic, where Unlike with a vaccine or an antibody, the toxicology is much more challenging and has to be done much more carefully. The road for that is much longer. So I'm hopeful. There's a reverse transcriptase inhibitor that looks promising. Would be great to see that happen. That would really, as you point out, make treating COVID just like treating the flu, where once you start coming down with it, you could take one of these small molecule drugs and do so safely and take it at home and not have to be admitted to the hospital and all the things you have to have with a drug that has to be infused. So that is the ultimate end game. I'm optimistic we will be in a much better place long before we get that. But in terms of making sure that coronavirus doesn't come back over and over again, that's a very important part of the strategy.
Okay. I'm glad to see that you've joined me on the optimistic in the optimistic camp. I know that's a standing joke between the two of us. So we've talked a little bit about testing. We've talked a little bit about treatment. Let's talk about vaccines. So I know that you weren't personally involved in the development of vaccines, but you have a sort of particular perch that you sit on as the editor of Science to sort of see how things have evolved over time. And I'm interested to know what has stood out to you about the development curve for the vaccines. And can you talk in particular about why we're looking at mRNA vaccines and what made their rapid development possible?
Yeah, well, people were working for years on the idea of an mRNA vaccine, or of the idea of mRNA as basically a vehicle for gene therapy, where you would use mRNA to introduce any protein into the body. And there's decades of basic research that went into that. And if that hadn't been done, we wouldn't be in the position that we're in right now. And one of the people who doesn't get enough credit for that is someone named Katie Carrico, who was a professor at Penn and now is an important employee at the BioNTech firm that created what we call the Pfizer vaccine. It really should be the Carrico vaccine, although there's a lot of other smart people who have worked on that. But if that technology hadn't been building up, we wouldn't be in the situation that we're in now, on the good side. I think generally, and I have to say, I was one of the people who thought that it was too speculative to try the mRNA vaccine. I thought it was more likely that the adenovirus vaccine or even the inactivated virus would be the quickest way to get there. But you got to give the Pfizer BioNTech folks a lot of credit, and you have to give a lot of credit to Barney Graham and Jason McClellan and Kizzmekia Corbett. When they sent us the structure of the spike protein, they were already formulating what we now call the Mrna Vaccine.
Right. So
those folks deserve a lot of credit. And I am personally invested in this in one way, which is that I'm in the Novavax clinical trial. I'm patient number 43. And I did that because I think that's a promising vaccine. It's a nanoparticle with the engineered spike protein in it. And very anxious to see that get to market, because it's easy to store and it should have all the advantages of the mRNA vaccine, except much easier to manufacture and store. And so I put my money where my mouth was on that, on Novavax's product, and we'll see if it ends up working out.
Yeah. It's interesting because I think that prior to the as the vaccines were first starting to be developed, if you had done a survey of scientists, they would not have bet on mRNA vaccines. But now I feel like everybody's saying, "Oh yeah, I thought it was mRNA vaccines all along." So
no, I think there's too many emails from me saying I didn't think mRNA vaccines were going to work for me to revise history in that way.
So I feel comfortable saying this. We're both science nerds. I hope you feel comfortable with my saying that about you. What has impressed you most about the science around COVID-19? I know that you and I were texting furiously when the Regeneron studies first came out. I know this because, truth be told, I was actually in the middle of a leadership retreat here at the University of Notre Dame, and somebody asked me a question while I was texting with you about the Regeneron studies, and I didn't quite catch it. So anyway, so what had got you so excited? What's made you sort of just stop and think, wow, when you've seen the science?
Yeah, I was excited about those antibodies, but I think the variants, well, I think the vaccines are going to do fine against the variants. The monoclonal antibodies are probably going to have a harder time because there's just either one or two of them, and it's easy enough for a mutation to hit that one epitope. No, I think what has amazed me the most really is just the extent to which so many people dropped what they were doing to work on this, rearrange their lives, people whose families may have been either impacted with the virus itself or by the effects of the pandemic, kids not in school, or family member losing a job, or a family member getting sick. And yet the valiant troops of science showed up day after day after day to get us this deep understanding of how this whole thing works, and to get us these vaccines, which do appear to be able to get us to where we can have, at least maybe by the fall, Notre Dame can have close to a normal school year, with fans at the football games and parents coming from move-in and all those things that we've been so desperately hoping would happen again. I think, it looks like there's an excellent chance we'll get a good portion of that, and these vaccines are the credit, but the vaccines are standing on the shoulders of lots of basic science that has gone on over the years, and also a lot of basic work in the last year to understand the behavior of the virus and how the various parts of the immune system respond to it and to the vaccine.
So is there a part of you that thinks about everything that we've learned about the basic science that made it possible for us to develop these vaccines so quickly, and what that means about funding for basic science? Have you spent time thinking about that?
Oh yeah, well, the American Association for the Advancement of Science is very committed to robust funding for science around the country. And my boss, Sudip Parikh, it's certainly important in his job description to appear before Congress and give good reasons why support for science should be there. And this is, if we've ever had a moment to make that case, in the last 20 or 30 years, this is certainly it. I mean, a lot of people believe that science is what's going to get us to the other side of the pandemic. I worry that not everyone is seeing that or wants to see it, and that it won't register. And I was more worried about that, I don't know, around the end of the year or so, when it was less clear that we might actually make it to the other side of this. Now I see that there seems to be a building appreciation for the fact that science has produced this. We're seeing people become less hesitant about taking the vaccine, and we're seeing less sort of arguing about the various kinds of non-pharmaceutical interventions that we need to be doing. So that's all going in the right direction, and let's hope that ends up leading to greater support for basic research at Notre Dame and lots of other universities around the country.
Absolutely. So I'm gonna push a little bit on this, how people perceive science, whether at this particular point in the pandemic or more broadly. there are some parts of society, we certainly see it all over various corners of the internet, that, use COVID-19 as an example of, well, at some point the scientists said this, and then they said that, and then they said this other thing. And this is all a sign that researchers don't actually know what they're talking about. And so how do we as members of the scientific community push back against that sentiment, push back against those conversations that are occurring? And how do we go about communicating more effectively to the general public about what the scientific method is like and how we should expect science to evolve, especially around a brand new issue like coronavirus?
Yeah, I mean, this is our moment to figure this out, and we need to desperately. I think, and there's several pieces of this, and in my role writing editorials or soliciting them, or other parts of commentary for the journals, these are a set of topics that I'm particularly focused on, and will be even more so in the next year. I think that the biggest problem we have is that we have allowed the rest of the world to think of science as something that drops out of the sky in a textbook and that is fixed. And that's because we've sat by while we let people teach it that way. We know that's not what it is. We know that science is a living, breathing, dramatic, honorably self-correcting process carried out by fallible human beings who argue and propose things that are wrong, and sometimes have a hard time admitting that their hypotheses are incorrect, and do all the same things that people in every other profession do. And pop culture hasn't helped us, because there's lots of TV shows about physicians and lawyers, and very few, and law enforcement, and very few about scientists. And even those that are there tend to either be very sort of sci-fi and not realistic about what goes on, or poke fun, which is fun, of course we deserve at our nerdiness. But they don't really take anyone into the real life drama of creating an enduring scientific record that we're all in the process of trying to create. So we need help from popular culture on that, to give us some real stories of real scientists that inspire the next generation and help everyone understand that this is a process. Now, we don't help ourselves in at least two ways that I can think of. One is when we say something prematurely and then have to correct it without explaining that this is our best understanding at this particular moment. And certainly with masks and COVID, we had that, because unfortunately at the beginning, there was confusion about masks. It was actually an interview in Science with the head of the China CDC that was a big part of turning the tide on that. But people who want to attack us are going to say, well, see, 6 months ago, you told us we didn't need to wear a mask. Now you say we do. Every time that happens, that makes our job that much harder. The second thing that I think has really hurt us is that we want people to appreciate everything we do all at once. And not everybody is going to be able to do that, because we spend our lives learning all this jargon and all these principles and all of that stuff. And we can't expect people in the wide public to suddenly decide that, oh yes, the earth is billions of years old and life got here through natural selection and the climate is changing because of human activity. I want everybody to understand and appreciate all of those things, but most people have to get there one step at a time. So we have an opportunity to begin that process now, because if the vaccine allows people to hug their children and go to sporting events and do all the things they want to do, then that's a way to draw them into understanding all of our principles. But it's unrealistic for us to think that everybody out there is going to appreciate every single idea in science all at once. We're going to have to get there gradually.
Okay. So Holden, imagine that you were on a video cast and you had a provost captive. Imagine that if you can. What would you want all of us in the academy, what do you want us to do to help contribute to solving this particular thorny issue? What, training our graduate students differently, doing some training for our faculty, what do you think would make the biggest difference?
Yeah, so not everybody would agree with me about this, but I don't think it's a good idea to try to get every single scientist to be a great ambassador for science. Some of us are better at it than others. And, people ask me all the time, how do I get my climate denying uncle to understand that COVID is real? And I tell them, well, the worst thing you could do is print out all of my editorials and hand them to him, because my editorials are written for other scientists. They're not written for your climate denying uncle. So I think we need to be thoughtful with a real strategy for how we're going to do this, beyond just saying everybody needs to take a communications class and learn to communicate more about this. Most of us aren't going to get invited to the Kiwanis Club of South Bend to give a talk about all of these things. So we need to delegate these tasks to the people who are good at it. There are a few people like Nancy Messonnier or Tony Fauci who are good at science and good at communicating, but most of us are better at one than we are at the other. And so the ones that are good at it, we need to encourage them. And the ones who need to stay in the lab and do their thing and talk to other scientists, they need to do that. And the biggest hurdle I see there is that, unfortunately, a lot of our faculty colleagues don't view communicating science as real work compared to doing research. And we need to fight against that, because not communicating science well is what has gotten us into this mess we're in. If we had done a better job of planning for that, we could have saved lives this year, and we might have exited the pandemic by now.
Mm-hmm. Okay. Holden, contrary to popular opinion, researchers and scientists are actually human beings. And just like everybody else, their lives have been disrupted by the coronavirus pandemic, whether it's because their labs were shut down for a little while, or longer term, whether their labs are operating at reduced capacity, or they have children who are in school, it's taking longer to get things reviewed at journals, et cetera. So what are your biggest concerns about the disruption that COVID has caused for scientists?
Well, the biggest thing is the disproportionate way that it has affected people. If your kids are grown, then you had more time to do science. A lot of people, depending on whether you had loved ones who became ill and things like that. So I heard from people who said, oh yeah, I'm writing up even more papers. But for young parents and for mothers in particular, the data are clear that this has had a detrimental effect on their productivity. And that's basically just magnifying the inequity that was already there, just as COVID has magnified many other inequities that we've had in this country and around the world. So I'm very worried about that. I'm hopeful that this will spur universities to have more enlightened policies around making sure that folks are thriving regardless of their parental status or their gender identity or anything else. And we've already had one editorial by Katie Collins about this, and we'll have some more stuff coming about this, both research on the data that are coming in and also, commentary and policy pieces about what we can can do about it. So that's a big, for the academy, that's something that I'm particularly worried about. I'm also worried about the graduate students who are graduating into this economy. I happen to have one of them in my family who's a PhD student in psychology. Fortunately, he's in his second year, so hopefully by the time he gets his PhD, things will have evened out a little bit. But for the graduate students who are graduating right now, I'm hopeful that the universities will step up and continue to assist them while we get to a better place. When you and I were provost, we talked about this a lot. A graduate student who doesn't get a job is not good for them or their university or for science in general. And so the institutions and the scientific enterprise needs to take ownership of that problem and make sure that when we get somebody to make the bold decision to get a PhD, that we do everything we can to make sure that they're thriving when they get done.
Okay. Holden, tell me a little bit about how the pandemic has changed the way that science operates, or the other journals in the science family. And will those things endure beyond the pandemic and become permanent ways of doing things? How about academic research and publishing more broadly? I also want to weave into this question something that's come from the audience about how do you see the role of open access, non-peer-reviewed platforms like bioRxiv? What do you see their role evolving over time as well?
Yeah, so on the first part, I think people are writing more. Unfortunately, that opportunity to write more, as we just discussed, is not being enjoyed by everyone at an equitable rate. But our submissions are up across the board. They're up in COVID by a lot, but they're still up in every other area of science. So people are learning how to do their research more efficiently and to publish more. And my guess is a year from now, our submissions are not going to go back down to where they were, that people have begun to think differently about writing and communicating science, and a lot of that change is permanent. Now, as for open access, as I said earlier, we like preprints. So the bioRxiv server is probably the largest preprint server. It's operated by Cold Spring Harbor. And among the colleagues that I have, certainly Richard Sever at Cold Spring Harbor, who operates bioRxiv, is an important colleague for me. So we love preprints. There's some misuse of preprints politically, and there are sometimes when they're communicated by the press prematurely that causes problems. But in our view, that's balanced out by the fact that it allows other researchers to benefit from the data much more quickly than waiting around for the peer review process to occur. Now, there's another question in there, I think, which is about open access journals. We have an open access journal, Science Advances. That's where researchers pay a fee, often from their lab budgets, to us to make their paper free for everyone in the world once it's published. We're pleased with Science Advances. It's a strong interdisciplinary journal, gets outstanding levels of citations and people looking at it, and we're happy about it. But if it was disconnected from the 5 subscription journals, we would have to charge a whole lot more for this charge. We call it the APC, the article processing charge, than we do. And that would not be good, because that would move many more costs onto laboratory budgets. So we like a balance between subscription journals and APC-driven OA journals. And we're hopeful that that'll stay there. A world where everything is an OA journal is a world where there's much more of a means test to publishing than I think either you or I would be comfortable with.
Okay. So anybody who reads Science, or certainly reads the editorials at the front of Science, knows that you were a very outspoken critic of the Trump administration, particularly with regards to how the administration handled the pandemic. So what concerns you most, and how are you feeling, at least in these early days, about the approach of the Biden-Harris administration?
Yeah, well, you know, you never know why you show up to do a job. Somebody throws you the keys and you try to figure it out. So I didn't know I was going to Science to be a columnist and a critic of the Trump administration, but it's something that I was honored to do, because I think that there were a lot of people out there, as I said, rearranging their lives to tackle the pandemic, who were coming home and turning on the news and seeing their president undermine everything that they were doing. So a lot of what I objected to was just the outright dishonesty. We know that Trump was tweeting that COVID was no worse than the flu. At the same time, he was telling Bob Woodward that he knew it was deadly and it spread through the air, and lots of other things like that. I think the biggest mistake they made, and the turning point in the whole thing, was when Nancy Messonnier and Tony Fauci were pulled off the podium, and Mike Pence and Donald Trump were put in their place, and the scientists had to clear everything that they communicated to the public through politicians who don't know any science. That doesn't make any sense. It was a terrible mistake that cost lots of people lives. I'm going to write editorials explaining how I'd like the Biden administration to do things differently here before too long. But on the big thing, which is, you know, are Tony Fauci and Rochelle Walensky and Nancy Messonnier standing at the podium without anybody lumbering over their shoulder or pushing them out of the way? No, they're out there speaking their minds. They've had a couple hiccups on some of the communication around a few things, but they've admitted that they were disconnected and they've corrected them. So if you get the communication part right, and it's unimpeded by politicians, then, you know, the rest of it will take care of itself. So there were lots of things that the Trump administration did that I thought were wrong. A lot of political maneuvering, but the biggest thing was just not allowing the scientists to speak directly to the public. And we've got that back now. And so that makes me more optimistic about the future.
Okay. I want to go ahead and take a question from the audience. And also I want to encourage anybody in the audience who wants to submit a question to do so on the same website where you're watching this streaming. So how important was previous research on SARS-CoV-1 in the development of current diagnostics and vaccines for SARS-CoV-2? If funding for SARS-CoV-1 had continued, would we be in a better position now? Any other prior research that had a big impact on current testing, treatment, vaccines?
Well, for sure, everything we knew about these viruses, sarbecovirus, they're called, has been a big help. And there are certain longtime coronavirus people, like my former colleague Ralph Barrick at the University of North Carolina, and Shuzheng Li, who was at the Wuhan Institute of Virology, who've been studying these viruses for years. And for sure, we benefited greatly from all of that. We were hoping there for a while that our immunity to some of these other coronaviruses was going to be a help with SARS-CoV-2. That didn't turn out to be the case, but the knowledge that we gained understanding the immune response and the behavior of sarbecoviruses for all these years has certainly turned out to be very, very important. What was the second part of the question?
Any other, it was I think you've covered it. Any
Okay.
other prior research?
Yeah.
So here's a question this is definitely from a Notre Dame faculty member. Please explain what it means when a paper appears on the CDC website and it was written by a group of scientists at the University of Notre Dame. Who published it? So no doubt this is in reference to an MMWR article, Truth in Advertising. I was one of the co-authors that was published by CDC on the recovery from the big spike in August here at Notre Dame.
Yeah, well, you probably know more about that than I do. Those papers don't come to me, but thank you for doing that. And I mean, again, as far as the CDC is concerned, it's never been, it's hard to think of things that have happened in science policy that I've been happier about than having the CDC back. I think that Dr. Walensky is doing a tremendous job. And there are a lot of hardworking people at the CDC who were very, very frustrated for 4 years. And thank goodness they hung in there, and now they're getting to do their job again.
Yeah. So just to provide a little more detail on that particular paper, I'll just say that that particular paper the CDC solicited was very interested in how we managed to recover from the spike and asked us to see if we could put things together to write it up. And even so, even though we were solicited to write it up, there were 7 layers of review at the CDC before it got published, both scientific review and, I mean, actually 7 different layers of scientific review. They were all scientific reviews. So anyway, so.
I can imagine that they would have, and that is more stringent review than we would have, because you know, that becomes official guidance if it's on their website.
Right. So what's the status of the nasal spray vaccine? Is it in human trials yet?
I don't know. Whenever I get a question like that, I have to be careful because I'm not allowed to comment on papers that might be submitted to science. So remembering whether they have been or not is always a challenge. I know that, let's just say, I know there's a lot of work going on that, and it is needed because while it is starting to look like the systemic vaccine does limit transmission, a nasal spray vaccine would be very easy to administer and might have a better chance of making sure that no vaccinated person became an asymptomatic carrier.
Why do you think it's taking, this is another question for all these questions have come from our audience. Why do you think it's taking so long to develop a COVID home testing kit?
Oh, I don't know. You know, the person that I rely on for this kind of thing is Michael Mrna, and he's been a very strong advocate for home COVID testing. There's no reason why, if you know, the health room at a high school can run the rapid antigen test, why you can't run it at home. So it probably has to do mostly with the process at the FDA. And the FDA has had a challenging year. I put a lot of pressure, along with several other people, on Stephen Hahn about a variety of political things. He eventually stood up and did the right thing. But the career folks at FDA have had a trying time. So my heart goes out to them. And they also don't have a permanent administrator yet. So hopefully that will get worked out soon as well. But I think Janet Woodcock and Peter Marks, who are probably the 2 most important career people there, have done a fantastic job. But it would be nice if they would put a little more emphasis on the at-home testing, because that certainly would change things for a lot of people.
Yeah. So Holden, as I know you're aware, in April of 2020, I'm going to go back to waiting for more questions to come in. So please, audience, send them in. But here's a question for me. As you know, in April of 2020, Science published an editorial written by the heads of the pontifical academies in Rome, which we we like here at Notre Dame, we just like to call them the Vatican scientists. The editorial was called "The Moment to See the Poor," and the editorial quotes from Pope Francis about how the pandemic has starkly revealed long-standing inequalities, and this was a moment for all of society to stop and really see everything that was going on around, acknowledge these enduring inequalities, and then make decisions about how we're going to act differently because of what we learned, because we don't want, the Holy Father was making the point that when we come out of the pandemic, we don't want to be in a world that's just like what the pre-pandemic world was like. So here at the University of Notre Dame, we've launched a whole initiative called Moment to See, Courage to Act, based on, and we probably account for, thousands of people reading that particular science editorial. So we're challenging people here on campus to think about, what do you see, and what do you want to be different about the world, and how are you going to act on that? So I'll turn that question to you, Holden. What do you see right now beyond maybe it's about COVID, maybe it's well beyond COVID. What do you see, and how are you going to choose to act on that?
Well, I think, first of all, thank you for your support for that editorial that those scientists had published with us in the past. And so when we were brainstorming who else we'd like to get a piece from, my very wise editor, who is the one who makes me sound as good as I do in my editorials, suggested that we go to those folks for another one. And, we were thrilled with the message of the piece, and also to have something from them. Well, I would like to believe that we're going to a more equitable and prosperous place for the whole world. I'm concerned about that, because even if you just look at the vaccines, I mean, we're all anxious to get our vaccine. I may have gotten mine, but I get to find out whether I got the real one when I qualify for another one. So I'm always checking my number to see if it's my turn yet. But the truth is that the U.S. is going to have plenty of vaccine by this summer, and everybody in the U.S. who wants to get vaccinated will, and that won't be true in most of the rest of the world. And so, that's something we all have to face up to. And at the time that piece was written, the poignancy and reality of that particular calculation wasn't here. So those folks were quite prescient and basically laying out the framework that we all need to be thinking about now, which is how do we push the governments to do more. I do have a lot of confidence in the people who are running COVAX. Sir Andrew Whitty is a longtime business colleague of mine. He used to live where we lived when he worked for GlaxoSmithKline, and he's doing a great job assembling enough vaccines to distribute around the world. But we all should support that. And, the Biden administration just gave him some money, and the Novavax vaccine, I think, will be the cornerstone of their efforts. So we need to make sure that they succeed. And if they do, then that'll be better than we did with HIV and Ebola and a lot of other global infectious diseases that didn't really reflect very well on the United States values in terms of how they were worked out.
Okay, we just have time for a couple more questions. What do you think about the SARS-CoV-2 variant? So you mentioned how some monoclonal antibodies might be less effective. Do you think that some of those variants are more lethal?
I'm not an epidemiologist or a virologist. I just watch them all argue about things and then try to communicate the consensus. And most of the time through this, the consensus of the experts has always been pretty clear. I would say right now there's a pretty big division among very serious people who've been doing this for a long time over how serious the variants are. There are some people who think that the 117, which, you know, try not to name them after places. So that's the one that people commonly refer to as the UK variant, that it's going to cause another huge spike in the spring. And that's certainly the simplest and safest assumption, because if it doesn't, then we'll all be happy. And if it does, then it'd be a good thing to be prepared for it. But I would say about half of the people in my Twitter feed that I look to as the experts think that either there'll be a smaller wave, or maybe this decline in cases will continue to happen before it gets going. That's a riskier prediction to make, but there are serious people making that. And the good thing about that one is that the vaccines are rock solid against 117, even though it does seem to spread more easily. The 351, which is the so-called South Africa variant, does get around the vaccine. We are going to have variants that get around the vaccine over the next several years. That's unavoidable. But there's reason to believe both that the T-cell response that's induced by the vaccine could be quite good against making sure that that variant doesn't cause severe disease or hospitalization. And it's also very unknown why it isn't spreading faster. The South Africa curve went all the way back down to the baseline. Now, they did a great job with their masking and social distancing and all of that, but it does appear possible to manage that particular variant with interventions that we know how to do. So I guess I'm on the more optimistic side. Maybe we have a little bit more of a plateau than we'd like to have right now with 117, and 351 comes around slowly enough that we can all get a booster vaccine before it becomes a real big problem. But there are outstanding epidemiologists who think that's a Pollyannish view, and that 117 is going to be a big problem for us in April.
All right, I'm going to ask you 3 rapid fire questions. Okay. Number 1, do you think COVID-19 is going to motivate students to go into STEM fields or demotivate them?
Motivate. I think, that's all you wanted?
No, you can say why.
Well, I think particularly for medicine, one thing I'm happy about, I mean, my generation wanted to go to medical school because of the television program MASH. The next generation wanted to go because of Grey's Anatomy. And now we're going to have students who want to go to medical school because of real scientists. And that's a good thing for the world.
Okay. So here's the top 3 questions. So this session is about COVID, but there is a lot of fantastic science going on across fields. So when you look back on the year 2020, what would you point to as the 3 most exciting scientific developments, non-COVID scientific developments?
Yeah, so the DeepMind protein folding algorithm, no question, that is huge. It hasn't been in a peer-reviewed publication yet, but it was presented at a conference and reported around the world, and it's astonishing that that the DeepMind group has solved the protein folding problem to the extent they have. It's another one of these things. When I was in graduate school, I would have told you nobody's ever going to do that. I think that the ultra high resolution cryo-EM of ferritin, that was in Nature. So just to show you that I'm mildly objective, that's a pretty extraordinary thing to have atomic distances from a non-crystallized protein. And then I think landing a probe on an asteroid, Bennu, was a pretty startling feat. And if you give me a 4th one, I'll give you quantum computing to solve theoretical chemistry problems.
Okay, that's a pretty good
I
top
snuck
four.
a fourth one in there.
There we go. I've got, in our last minute, I've got one more top three question for you. So I know that you're a jazz fan. If you were going to recommend 3 jazz records to our audience for people who are beginners, so for their introduction to jazz, what are your top 3 albums for people to go listen to?
Okay, it's hard not to start with Kinda Blue. That's the most famous jazz album ever. Miles Davis, John Coltrane, Cannonball Adderley. The Birth of Modal Jazz. I think it's the biggest selling jazz album ever. A Love Supreme by John Coltrane. The birth of, much more improvisational jazz. Extraordinary moment in John Coltrane's life because he got kicked out of Miles Davis's band and then he got his life together and he made even better music than he had before. And Love Supreme is very meaningful in terms of the history of African American music and Black history in general. And then, since Chick Corea passed away last week, need to put a Chick Corea album in there. And I'm going to sneak in 2 again. If you like jazz rock, then Romantic Warrior would be the one. And if you like things that are, closer to straight ahead jazz, Crystal Silence, which is Chick Corea and Gary Burton, is pretty unbeatable. But you want to go another couple hours, I could go through a bunch of other albums and who else is on them.
We'll be sure to post your jazz album list on the Notre Dame Provost website for everybody to get access to. I thank you so much, Holden, for just a wonderful conversation. We'll be back at the same time next week. Next week, the topic for State of Science with Holden again will be about the role of collaboration and interdisciplinary science in a post-pandemic world. Same bat time, same bat channel. Hope we'll see you again next week. Thank you so much, Holden.
Terrific. Enjoyed it. Thanks so much for having me on.